Hello. Firstly, I would like to introduce myself. My name is George Coleman and I was a Senior Project Manager for BT where I worked for 44 years, retiring approximately 4 years ago. I started my career as an electrical engineer and went on to become a project manager, managing mostly technology and electrical type projects, building data centres and technology projects all around the world. I now fill my time as a STEM ambassador. I've been a STEM ambassador for approximately 6 years and I enjoy working in the schools where I like to promote engineering and its importance in the world today. I want to talk to you today about energy and the types of energy that we use in this country. I will talk first about the non-renewable types of energy that we use today and are available to us. I'll then move on to look at the renewable types of energy that are available to us and if and how we use them today. And lastly, I'll look at how all these types of energy plants are looked after before giving a summary of what I have spoken about. Let's look first at the non-renewables. The four main types of non-renewables in use in this country are gas, oil, coal and nuclear, as you can see from the PowerPoint slide. Looking at the slide, we'll start at the top left first, gas. As you can see from the picture, lots of smoke and steam coming out of the gas power plant. Therefore, the main problem there is it pollutes the atmosphere. Carbon gases, greenhouse gases. Another problem with gas, of course, is that it is a finite resource. It will run out one day. We don't know how long, but it will run out. At the moment, we get most of our gas from the North Sea, although at times of high usage, it does have to be imported from mainland Europe through pipelines. So, summarise on gas, it will run out one day. We don't have enough of it in this country to supply us during times of high usage, and of course it requires a big complicated power plant. Moving on, we'll go to the bottom left and we'll look at oil. Oil has very similar problems to gas. As you can see from the picture again, lots of atmospheric pollution. Pollutes the air, again carbon and greenhouse gases. Same situation as with gas as well, in that oil will run out one day. At the moment, again, we get most of our oil from the North Sea, although we do import it also from the Middle East and from Eastern Europe, mostly Russia. So oil is very similar to gas, big complicated power plant, pollutes the atmosphere, and of course oil will run out one day. Again, can't say how long, but it definitely will run out. Moving round again, we move on to coal. Coal is probably the most polluting fuel that is in use today. Again, as you can see there from the picture, lots of smoke coming out of the chimneys, and of course coal is very difficult to get as well. Coal has to be mined. We don't have enough coal in this country to provide the power stations anymore, so the coal that we do use is mostly imported. And of course, as with the oil and gas, the coal will also run out one day. So again, you could argue very similar problems to oil and gas, only even more so in that coal will run out. It pollutes the atmosphere and a big complicated power station. One thing with coal in this country is that at the moment we are running down the use of coal-fired power stations, and in fact I do understand that during this summer 2020 there are times we've been able to switch off all of our coal-fired power stations and just use the oil, gas, and the last fuel we'll come to, which is nuclear. So top right there, looking at nuclear. Of course, the first problem with nuclear is that the fuel itself is very unstable and highly toxic. Many of you may be aware there have been problems with nuclear power plants in other parts of the world that have meant the closure of complete cities, thinking of in Japan and in Eastern Europe. Nuclear fuel itself is more efficient than the other fuels, although again in its own way it does provide pollution, in that where the fuel is radioactive, it remains radioactive after it's burnt. And the way we get rid of it is to bury it in the ground, but it still remains radioactive for hundreds of years and therefore causes pollution in a different way. So to summarise all of these non-renewable plants, you have oil, gas and coal, which all pollute the atmosphere, will all run out one day and all require big complicated power plants. And you have nuclear, which causes less atmospheric pollution but is a highly toxic material, can be very dangerous, and again, as with the non-renewables, will run out one day. Let's look next at renewable energy, and we'll look at the two main types in use in this country today, which are, of course, wind power and solar power. I'm sure many of you have seen the big new types of windmills at the sides of roads or inside factory grounds. These windmills produce energy which is then stored in batteries and then converted and delivered to our homes and factories all around the country. They can be either isolated, as I've already said, on the sides of roads, or more likely in more remote areas you get wind farms where, as this picture is, lots of them are put up together, sometimes hundreds. They also build wind farms out in the sea, again in the North Sea, which is quite a windy area, and again you can have hundreds of these together. They do then of course have the problem of transmitting electricity back onto the land, but once all this is in place, it's actually quite a cheap way of producing energy because the wind is always there in this country. We live in quite a windy environment, especially say if you're up on the hills or out to sea. The other type of renewable energy which you may have seen is solar. Now many of you will have seen solar panels on tops of people's houses where they use them to power part of their house or even put power back into the grid. What you may not have seen is solar farms. Some farmers now, instead of growing crops in their field, are actually having fields full of solar panels where again the energy is stored into batteries and then delivered to our homes and factories. So to summarise there, the good thing about wind and solar power, of course, is that the source is free, the wind and the sun. Neither of them will ever run out, and of course they cause absolutely no pollution whatsoever. The downside is that the energy does have to be stored in batteries and converted before it can be transmitted to our homes and factories for use. Moving on with renewable energy, two types which you may not have seen are wave power and hydropower. Looking at the wave power first, in some respects this uses a very similar principle to the wind power, except that the turbines used to generate the electricity are actually under the water. So as the tide flows in and out, or the waves come in and out, they cause movement which in turn moves the turbines, which then generates the electricity. I don't know of anywhere where that's actually in use in this country, although it is certainly a technology that could be used. Hydropower tends to be more based on rivers, where dams will be built and then the water flowing over the dam will be used to turn the turbines, which again in turn generate the electricity. This is in use in many places around the world. In fact, I have been to the Hoover Dam, which is a well-known dam in America and quite a tourist attraction. If you ever get a chance to go there, it's well worth looking at. You can see from the picture, it's hopefully fairly self-explanatory. Basically, you build a wall across a river, the water flows over the top, and that water flowing over the top generates the electricity. As with the wind and the solar power, the advantage of both of these again is of course that the source is free. If a river's flowing, it will turn the generators, and if the tide's coming in and out, which it does twice a day in this country, it will turn the generators. So again, the source is free. The same problems as the other, you then have to capture the electricity and convert it before you can then deliver it to our homes and factories. The last type of renewable energy that I want to talk about is called geothermal. This is a much less well-known type of energy. If you look at the slide, you'll see that the picture on the top left is a volcano. The reason I've shown this picture is to demonstrate that inside the centre of the Earth there is lots of heat and energy just waiting to get out, and a volcano is a place where it finds a point to get out. If you look at the picture on the bottom right, this is a power plant that uses that heat and energy inside the centre of the Earth to generate electricity. Again, because this uses totally natural heat from the centre of the Earth, this is a totally clean way of generating energy and it causes no pollution whatsoever. I don't know of anywhere in this country where we actually use this, although again it is definitely something that could be used. The last thing I wanted to talk about is who actually designs, builds and looks after all of these types of energy plants, whether they be non-renewable or renewable. The answer to that, of course, is engineers. You have the design engineers who do all the planning, you have the build engineers who actually build the power plants, and then of course you have the maintenance engineers who look after it all once it's operational. None of this energy would be available to us without engineers from the very start to the very finish. And this is why I believe engineering is one of the most important roles in this country. Nothing in this country could work without engineers. And so to summarise the whole presentation, the main difference between renewable and non-renewable is that renewable energy will not run out and renewable energy does not cause pollution. Non-renewable energy will run out one day and does cause pollution. And the last, and for me probably the most important point, is that all these types of energy need engineers to develop, design, build and look after them. I hope you enjoyed the presentation. Thank you.